This is page 2 of review worksheet number 10, and we'll review worksheet for chapter 10. So starting with number 9, we're supposed to expand this logarithm, the expression. So the 3 is being multiplied by the x, and those are both being divided by the 2 and the y to the third. So when I expand this out, it's going to be the common log of 3 plus the common log of x, subtract the common log of 2, and then subtract the common log of y to the third, so it's going to be minus 3 times the log of y. So that is choice D. You just have to be careful, watch out for signs. Number 10, this is the common log of 100 over x, so it's the common log of 100. Subtract the common log of x using the properties of logarithms. And remember that this is a base 10 down here on a common log. And this term can be simplified because the exponent I raised 10 to get 100 is 2. So I can simplify that to 2 minus the common log of x, which is choice B. And then in number 11, also I'm expanding. So 3 is being multiplied by x squared. So it's going to be the common log of 3 plus the common log of x squared, which is 2 times the common log of x. And so that would be choice C. And number 12, I'm going to write the formula here. I've got to find the number of years that this investment takes to double. If it starts at 1800, here's my interest rate, and they say it compounds semi-annually. So the number of compounding periods is 2. They pay my interest twice a year. So I'm going to write the equation here. So my ending amount, which is twice 1800, because I'm looking for it to double, is the starting amount of 1800 times 1 plus the interest rate is 6.4%. And remember, I've got to divide that by 2. So 0.064 divided by 2. And then it's being raised to the power of time, and that's the unknown. And remember, I have to double that. I have to put the same number in both places because I'm compounding twice as frequently as I would in a year, and so there's twice as many compounding periods. So then I already did this one out to the side, so I'm just going to talk through it where there's enough space. So I take that equation and I simplify this to be 3.2%, which is half of 6.4%. So I write this base as 1.032. Now I want to isolate this exponential term, so I divide both sides by 1800. So on the left I have 2 equals 1 and 32 thousandths, and that's raised to the 2t. And the variable is here. I want to get it down on the ground. So I log both sides, and I bring that down to the front when I do that. And so if I just look at this, I now have the log of the left side 2 equals the log of the right side, and I brought that 2t down to the front. So now I'm going to isolate this t, I'm going to divide both sides by the 2 and that log, and now t is equal to this value, and so when I punch that in my calculator and simplify it, I get about 11.0 years, which is choice E. Okay, for number 13, I'm investing 400 at 5%, and I want to know how long is it going to take it to reach 5,000. This compounds just once a year annually, so it's a simple interest problem. So my equation is going to be that my ending amount that I want to get, 5,000, will be the starting amount of 400 times 1 plus 5%, so 1.05 to the power of time. So I've worked that out on a separate sheet here. So that's the equation I'm starting with. So I want to isolate this exponential term so that I can take the log of both sides because, again, the unknown is in the exponent. So I need to get it down to solve it. But first I'm going to divide both sides by 400. So when I do that, I get 12 and a half on the left side is equal to 1 5/100 to the power of t. So now I take the log of both sides and bring that t down to the front. Whoops. And so now I've got this. The log of 12.5 is equal to t times the log of 1.05. So I divide both sides by the log of 1.05, and I've now isolated this t. So t is this expression, and I punch that in, and I get about 51.8 years. So this is, they asked for it to the nearest tenth. Okay. The next word problem is this endangered species. It starts at 10,000 and it's decreasing at 3% a year. And how many years is it going to take before only 80% of it remain? So what they're looking at is when 80% of 10,000 is 80,000. So they're saying if that's the ending amount or value, and it starts at 10,000, its rate of decay is 1 minus 3%. And again, they want to know how long will that take. So I've done that one on separate paper. I start off like this, and I'm going to simplify. 1 minus 3% is 97%. So at the end of each year, you have 97% of what you started with. So I want to isolate this exponential term, and I'm going to end up having to bring that t down. So I divide both sides by 10,000, and I get, 80%, 0.8 on the left is equal to 97 hundredths times to the power of t. So I log both sides and bring that t down. So I'm to here. And then I divide through both sides by the log of 0.97. So I've isolated this t. So t is this expression, and when I punch it in, I get about 7.3 years. So about 7.3 years. Okay, now we're back to, in 15 we've got an equation to solve. So the left side is in log and the right side's a number, so I'm going to go for log equals number. So I can combine this as I'm adding these exponents, so I must be multiplying the 9 by 4. So I get the log base x of 36 equals 2. And now I'm going to rewrite that in exponential form. X squared is 36. So x is positive or negative square root of 36, or 6. But it will be undefined. And for this, and so we're only given the choice of 6, so we'll take 6. Okay, anyway, now the exponent can be negative, of course, with logs. So for number 16, the log base x of 9 equals 2. So what is the exponent that I raise this base to? 2. Negative 2 is the exponent I raise x to get a 9. So I'm just going to rewrite this as x to the negative 2 equals 9. And then I need to get this to be an x to the first. So if I raise both sides to the reciprocal power, I raise both sides to the negative 1/2, I get x equals 9 to the negative 1/2, which says the square root of 9 to the negative 1. So the reciprocal of the square root of 9, so the reciprocal of 3, or 1/3, which is choice D. Number 17, I have an equation. I've got logs on one side and a number. It's probably just going to be easiest to get a log equals number. So I'm going to, these two exponents are being subtracted. So that's division when I put them back together. So that's x squared minus 4, which I'm going to actually factor to be x plus 2, x minus 2, because it will simplify things in the beginning. Divided by this x plus 2 is equal to 2. So then I can simplify. I can cancel those out. So now I've just got the log base 3 of x minus 2 is 2. So now I can rewrite this in exponential form. So 3 to the second power is equal to x minus 2. So 9 is equal to x minus 2. So x is equal to 11. Oops. Okay, number 18. Let's see here. I've got log number, so I'm going to combine the left side. So we get log base 3 of, and this is going to be x plus 2 times 6. And then I'm going to rewrite this in exponential form. 3 to the third equals that. So 3 to the third power equals 6x plus 12. So 9 is 6x plus 12. So let's see. Subtracting 12 from both sides. Negative 3. Oh, I did something wrong here. Oh, what am I doing? 9. That's 27. Sorry. So subtracting 12, I get 15 equals 6x. And dividing through by 6, x is equal to 5 halves. Okay. Number 19, they said if this expression is r, find the log of r. So the log of this expression, let's just rewrite it first in with an exponent of 1/3 since it's a cubic root. And this is a to the 2, b, and then c is in the denominator, so I'll call that c to the negative 1. So I've got I can use the exponent rules here. The log of a to the 2/3 plus the log of b to the 1/3 minus the log of c to the negative 1/3. Or actually plus, sorry. We'll write it like that. And then we'll bring these exponents down, or out to the front. Okay, okay, so this is going to be 2/3 times the log of a plus 1/3 times the log of b minus 1/3 times the log of c. So that matches choice D. So the last one on this page, log equation, let's rewrite this in exponential form, solving for this base of x. X to the 1/3 equals 2. So raising both these to the reciprocal power, which is 3, I can see that x is equal to 8, which makes sense. Be sure these all make sense, that you check them. You know, this says the cubic root of 8 is 2. So that's choice C, and that's it for that page.